This is SpaceTime, Series 20, Episode 72. Coming up on SpaceTime, we bid a final farewell to NASA's great Cassini spacecraft, the possible discovery of intermediate-sized black holes, and the most powerful solar flares of the current solar cycle. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
After an historic mission lasting 20 years, including 13 years of groundbreaking scientific observations of the majestic ringed world of Saturn and its many moons, Cassini's journey of exploration has finally come to an end. On September the 15th at 4:53 in the morning US Pacific Daylight Time, that's 9:53 in the evening Australian Eastern Standard Time, after a 5-minute roll manoeuvre, Cassini began its suicidal death plunge into Saturn's atmosphere, triggering the ultimate demise of the spacecraft. The mission's end began on Monday when Cassini undertook a final close encounter flyby of Saturn's largest moon, Titan, flying just 119,049 kilometres above the haze-shrouded moon, travelling at over 21,000 kilometres an hour. The flyby was Cassini's 127th targeted encounter with Titan, giving scientists one final opportunity for close-up observations of the lakes and seas of liquid hydrocarbons spread across the moon's northern polar regions, and a last chance to use its powerful radar to pierce the haze and make detailed observations of the surface. Cassini's radar looked for changes in Titan's methane and ethane lakes and seas and attempted to study the depth and composition of Titan's smaller lakes. Scientists also took the opportunity to search for Titan's Magic Island, a mysterious feature in one of the moon's seas that's changed its appearance over the course of several flybys. Scientists aren't sure what it is, whether it's an island or whether the feature's just a bunch of waves, bubbles, floating debris, or something entirely different. The gravitational perturbations caused by the Titan encounter flung the 2,150-kilogram Cassini spacecraft onto an intersecting trajectory designed to send it deep into Saturn's swirling cloud tops. The growing pressure of the gas giant's thick hydrogen, methane and ammonia atmosphere quickly sent Cassini tumbling out of control, ripping the spacecraft apart and turning what's left into a blackened, charred trail of debris. Before entering Saturn's atmosphere, Cassini took its final images of Saturn and Titan, sending them back to NASA's Deep Space Network ground stations. With its antenna locked on Earth, Cassini continued streaming back data and readings from its 12 scientific instruments as it hit the atmosphere at over 120,000 kilometres per hour. Soon, its thrusters were unable to maintain a stable trajectory, and the communications lock with Earth was lost about 1,510 kilometres above Saturn's swirling cloud tops. The CSIRO's Glenn Nagel is from NASA's Deep Space Communications Complex at Tidbinbilla near Canberra. I spoke to him in the lead-up to Cassini's mission end.
The Cassini spacecraft is going to end its life by plunging into Saturn's atmosphere, travelling at about 111,000 kilometres per hour. And at that speed, the thrusters will not be able to keep the spacecraft stable and will eventually go into a tumble, break up, and that will be the end of Cassini's mission as a shooting star in the atmosphere of Saturn.
Why are they deciding to end Cassini this way?
NASA has a set of rules, the planetary protection laws. Over the years, we've learned a lot more, particularly about Saturn's moons, Titan and Enceladus. These are two worlds that have the potential, at least, to support some kind of life. So we want to protect those environments. If they'd lost control of Cassini after it had run out of fuel and we just let it wander around aimlessly, it could have potentially collided with one of these worlds and brought contaminants, including maybe some hardy Earth bacteria that have stuck with the spacecraft over the years. So we want to ensure that we keep pristine environments out there for any other forms of life.
Yeah, that idea of Earth-based contaminants isn't that far-fetched, is it? I think it was the Apollo 12 mission that retrieved a camera from a probe that landed on the moon, and they found what appeared to be Earth bacteria on it.
Yeah, and it's quite possible. And they've also found things like tardigrades, these little tiny creatures that are microscopic to the human eye, but they can survive incredibly harsh conditions over long periods of time, including the vacuum of space. space. So protecting the space environment, very important to our future, especially if we're trying to find life. We want to find alien life, not life from our own planet.
Yeah, these little desiccated moss piglets, I think is another name that's used to describe tardigrades. They've only just sequenced their genome recently, and they found they're very closely related to nematodes and also spiders.
Yeah, fascinating creatures, can survive deep freeze and a whole range of other things. So
Radiation.
maybe they can actually, they can even maybe potentially in the future point the way about how humans may be able to survive long journeys into space.
Tell me about the role NASA's Deep Space Communications Complex playing during the end of mission phase. I know it's been involved through the whole mission.
Yeah, so we've been literally tracking Cassini since the day she launched back in 1997 throughout its entire journey. But for the grand finale of this final plunge, our station in California and our tracking station here in Canberra playing the key roles. So about 11 hours before actual final plunge in, all the last data from the recorders on board the spacecraft, all the last pictures, all the last information that Cassini has collected over the last few weeks, will be downloaded straight to our Californian station. That'll wipe the recorders, cleaning them, so that then the spacecraft goes into full real-time science mode. And that is having its main instruments collecting data, rather than storing it on board, transmit it back as soon as has collected that information. And that's going to be the job for our Canberra station. So starting at about 1 p.m. in the afternoon, we'll start linking up to the spacecraft there. At about 3:15, data will start streaming down as the spacecraft gets closer and closer to Saturn. So we'll be learning more about the planet's atmosphere, literally tasting the composition of that atmosphere. We'll be looking more at the magnetic field of Saturn, trying to understand a bit more about the rotational period. We actually don't know exactly how long a day is at Saturn. And to learn more about the interior of the planet and also just the mass of the rings in a bit more detail. So Cassini is literally going to be sending back data right up until the last moment, and we're going to be here in Canberra capturing that last breath of data.
And Cassini will enter Saturn's atmosphere about 9:53 Australian Eastern Standard Time. That's 11:53 in the morning, Greenwich Mean Time, 4:53 very early in the morning, US Pacific Daylight Time, and it'll probably only survive a few minutes after that, won't it?
Yes, NASA expects, based on the data that they've collected so far through a number of the recent deep dives, is that Saturn's atmosphere is a little denser than they are expecting at these particular altitudes. So they've been able to adjust the time. They're looking around about that 9:53, 9:54 period in the evening, Australian Eastern Standard Time. And what we should see is the signal indicating that the thrusters are firing on the spacecraft. So it's all the way through the deep dive. It'll keep its antenna pointed back towards Earth and have its signals received here in Canberra. As soon as we start to see fluctuation in that signal, it means the thrusters are firing, struggling against, the atmosphere, frictional forces building up on the spacecraft, trying to turn the spacecraft sort of away from its Earth-pointed direction with its antenna. And as soon as we start to see that signal, and we know those thrusters are firing and struggling to keep the spacecraft in its flight path, then we'll know we've got less than a minute, probably something maybe closer to 49 seconds before the spacecraft completely tumbles out of control and breaks up.
So Canberra will be the last station to get signal lock.
Yes, so we've got two antennas, our big 70-metre antenna, one of our brand new 34-metre diameter antennas locked in on the signal from Cassini. We've got very good processors here in place, incredibly sensitive receivers, so we expect to be able to pull in those tiny whispers as spacecraft ends up making its final plunge into the atmosphere.
Cassini's observations have spawned well over 4,000 scientific papers. Cassini was launched back on October the 15th, 1997, aboard a Titan 4B Centaur rocket from the Cape Canaveral Air Force Base in Florida on a 7-year journey to the Saturnian system, achieving Saturn orbit insertion on July the 1st, 2004.
Yeah, we see these spacecraft as very much part of our family. This is a spacecraft mission that was originally planned back in the 80s, went through a number of different variations, finally got some funding as a major frontier mission for NASA. It was the largest planetary spacecraft constructed, sent off on this long journey back and launching in October 1997, 7 years just to get to Saturn in the first place. And not just going straight out, of course, it had to do 2 flypaths of Venus and an Earth flyby, getting gravity assist to slingshot it out to Saturn. And then, of course, arriving there, and it was our tracking station here in Canberra that actually handled the arrival of Cassini at Saturn.
6 months later, on December 25th, Cassini deployed the European Space Agency's Huygens lander, which descended through the thick atmosphere of the mysterious Saturnian moon Titan, long considered to be a primordial version of the Earth. Huygens touched down on Titan on January the 14th, 2005.
People might not remember, Cassini was a two-part spacecraft. Huygens, a European probe to go and descend and land on the surface of Saturn's largest moon, Titan. And we captured all the data from that descent, entry and landing on the surface of quite a big world, amazing world out there at Saturn. And then through most key science moments, key mission moments, flybys and encounters with the surface of Titan.
Instruments aboard Huygens indicated the Titan's surface where the spacecraft landed was like cold, wet sand. Titan holds a special place for scientists. It's the only place in the solar system other than Earth where it rains. That rain forms rivers, which eventually flow into lakes and seas. Recent observations have also discovered complex prebiotic chemicals in Titan's atmosphere, which rain down onto its surface. Of course, the surface of Titan is so cold, water is frozen solid, forming much of the moon's bedrock. So instead of water, the liquids on Titan are hydrocarbons, methane and ethane. Surprisingly, it turns out Titan's lakes and seas are confined to the poles, with almost all of the liquid being at northern latitudes during the present epoch. Cassini found that most of Titan has no lakes, with vast stretches of linear sand dunes closer to the equator, similar to those in places like Namibia on Earth. Cassini also observed giant hydrocarbon clouds hovering over Titan's poles, and bright feathery clouds drifting across the landscape, dropping methane rain that darkened on the surface. More intriguing were indications of a possible liquid water ocean deep beneath the moon's surface.
Radio science experiments look at the lakes on the surface of that world, to have a look at the atmosphere and the dynamic storms there. So all along the way, we've been with Cassini, and she's become very much part of our daily lives, and it's going to be kind of sad, a bittersweet moment when we actually see that signal finally disappear after what has been nearly 20 years.
Every now and then I have another look at the images from Huygens as it landed on the surface of Titan, touching down on what was described to me as wet, cold sand.
Yes, this world turned out to have mountains and sand dunes and river systems and lakes on its surface, and then landing there with the Huygens probe, taking images of this sort of wet surface, a little bit like wet sand, or a creme brulee, if you like, a crusty surface, cracking through it and finding liquid underneath that surface, ice rocks on the surface. It's so cold there that water ice is literally like rock. And these were sort of curved rocks, rounded. So they'd been affected by liquid flowing across them, not liquid water, but liquid methane, creating these lakes on the surface. So it is an amazing world, and very similar, the science team says, to the way the Earth used to be maybe 3.5 billion years ago when life first appeared on our own planet.
Cassini did find strong evidence for liquid water below the frozen ice sheets of another Saturnian moon, Enceladus. Plumes of water were seen jetting out from geysers dotted across the spectacular Tiger Stripe formations at the Enceladian South Pole. Readings by Cassini indicate that, like the Jovian ice moon Europa, the Saturnian ice moon Enceladus has a global subsurface liquid water ocean deep beneath its frozen icy crust. And minerals detected in those plumes of water indicate the likely presence of hydrothermal vents on the subterranean seafloors of Enceladus. On Earth, similar features provide a rich chemical soup thought by many scientists to have spawned the first life on this planet. Only time will tell if the same things happened on Enceladus.
Yes, Enceladus, an ice-covered world, been discovered with an ocean below that surface, the cracks, the tiger stripes you mentioned, allowing these ice geysers to spray out into space, creating another very thin gossamer ring around Saturn itself. And this moon, of course, they threw Cassini through those icy geysers, through those plumes, and found out that this was liquid water. It was fizzy, it was carbonated with all sorts of natural gases, had indicators that there could be hydrothermal vents at the bottom of this ocean, similar to you find these hydrothermal vents with life all around them here on Earth, and also found in that water that there was the chemistry of life, some simple and some quite complex organic chemistry. So more fascinating things about these little worlds, and that's why we want to protect them, Titan and Enceladus, because they are just so amazing and have that potential for life.
Since April, Cassini's conducted a series of 22 weekly grand finale dives through the 2,000-kilometre gap between Saturn and its rings, providing close-up views of the inner and outer edges of the rings and the planet's small inner moons, as well as close encounters with the upper reaches of Saturn's atmosphere. Cassini discovered that Saturn's spectacular rings have far less mass than previously thought. That suggests they're far younger than previously thought, possibly just 120 million years old, the result of a moonlet being ripped apart by Saturn's gravity or collisions between moonlets. Scientists hypothesized that if the ring system was more massive, then it would be older because its combined gravity would have held it together, preventing it from being gradually eroded away over time through meteoroid collisions. But because Saturn's rings are a relatively recent addition, it means we're seeing Saturn now at a unique and certainly spectacular time in its evolution. The data Cassini supplied will continue keeping scientists busy for years to come.
Just every single day creates a new memory. Hundreds of thousands of images coming back, seeing these incredible worlds, looking at the rings, seeing fine structure in those rings, looking at the dynamic atmosphere of Saturn.
You've been following Cassini since its launch. For you, what's the most enduring memory?
I think some of the key moments that really stick in my mind are those times when Cassini has kind of looked back past Saturn and looked back home, actually seeing the Earth sort of sparkling there as a tiny pale blue dot in between the rings of Saturn, and even some images occasionally showing the moon sitting beside us, another tiny speck. So I think that puts the whole mission in perspective, not just seeing this beautiful ringed world, this amazing set of moons, a whole solar system of its own around that giant planet, but that view back home again and really understanding that in all this beauty of the cosmos, we're just another tiny little speck, in the vast void of space.
What about the rest of the team? Incredibly important day for them too.
It is. Our great team of engineers, technicians, spacecraft communication people, a wonderful, great team of Australians from the CSIRO, who've played this long and successful role in Cassini's mission. And we've been able to sort of demonstrate our incredible capabilities in this area in Australia. And I think that there's an enormous sense of pride that we take every single day, ensuring that we get this information out to the spacecraft, its command, so it knows what to do every single day, and to get the information home again, to process it and send it off to thousands of scientists around the world. And, of course, also to share it with all of us, the public, on the internet, so that we can actually become a part of this adventure. So understanding the Australian role and seeing that there's people behind all this incredible technology and the grandeur of space exploration is very important, and a very proud thing that we can sort of sit back at the end of the day and know once Cassini is gone that we have played such an important part in the success of its mission.
That's the CSIRO's Glenn Nagel from NASA's Deep Space Communications Network near Canberra. You're listening to SpaceTime. I'm Stuart Gary. NASA's New Horizons spacecraft has successfully awoken from hibernation as it continues its marathon mission to the distant Kuiper Belt object 2014 MU69. Mission managers at the Johns Hopkins University in Laurel, Maryland, say the 480-kilogram probe woke up from its 5-month hibernation period in good health. It's operating normally, with all systems coming back online just as expected. Over the next 3 days, mission operations teams will bring the spacecraft back into active mode, preparing it for a series of science instrument checkouts and then data collection activities that will last until mid-December. The 157-day hibernation period, which ended on September 11, was the spacecraft's first rest since before the historic Pluto flyby back in July 2015, and one of only 2 hibernation periods before its MU69 encounter. New Horizons is now over 5.82 billion kilometres from Earth, speeding through the Kuiper Belt towards a close flyby of MU69, slated for January 1st, 2019. The Kuiper Belt is a ring of comets, icy debris and frozen worlds, circling the Sun out in the dark reaches beyond the orbit of Neptune. Over the next few months, New Horizons will train its instruments on numerous distant Kuiper Belt objects, making long-distance observations while also continuously measuring the Kuiper Belt's radiation, dust and gas environment. Scientists also want to test the spacecraft's instruments in preparation for next year's approach to MU69, and they want to transmit a new suite of fault protection autonomy software to New Horizons' main computer in early October. Meanwhile, the science, mission design and operations teams are continuing to shape the details of the MU69 observation plan. In early December, New Horizons will carry out a course correction manoeuvre designed to set its arrival time at MU69. Then, on December the 22nd, New Horizons will go back into hibernation mode, where it will remain until June the 4th next year, when mission managers will wake the spacecraft for the last time to begin preparations for its MU69 encounter. At its current distance, signals from Earth take 5 hours and 24 minutes to reach New Horizons. In fact, the spacecraft is now just 593 million kilometres from MU69, and it will cover that remaining distance in just 476 days. A lot of mystery still surrounds 2014 MU69. Based on its brightness and distance, MU69 was first estimated to have a diameter of about 18 to 41 kilometres. However, more recent observations suggest it's no more than about 30 kilometres long and extremely elongated. Scientists now believe it may actually be a close or contact binary made up of two separate objects. In an occultation back on July the 17th this year, a two-lobed shape was revealed, with diameters of 18 and 20 kilometres respectively. MU69 has an orbital period, that is the time it takes to orbit the Sun, of just over 295 years. And it has an extremely low inclination and eccentricity compared to other Kuiper Belt objects. All of these factors combine to make MU69 an incredibly desirable object to study. But scientists will have to wait until January the 1st, 2019 before the encounter takes place. You're listening to SpaceTime. I'm Stuart Gary. Astronomers have found strong evidence for the existence of an intermediate-sized black hole hidden deep inside a massive gas cloud cluster near the centre of the Milky Way. The discovery, reported in the journal Nature Astronomy, could explain how supermassive black holes are formed in the hearts of galaxies. Until now, black holes only seem to have come in two sizes. There are stellar mass black holes up to maybe 100 or so times the mass of the Sun, which are formed from the collapse of massive stars. And then there are supermassive black holes, found in the hearts of most, if not all, galaxies, which contain millions to billions of times the mass of our Sun. However, astronomers have been unable to find any intermediate mass black holes, those with thousands to hundreds of thousands of solar masses. And despite countless searches, these have remained elusive. And despite numerous hypotheses, no satisfactory explanation for this lack of size range has ever been forthcoming. Now, a team of astronomers led by Dr. Tomohara Oka from Keio University in Japan have found the first clear evidence for the possible existence of a mid-sized black hole. The authors, using the Nobuyama radio telescope in Japan, detected strange behaviour in a large gas cloud known as CO 0.40-0.22 star, located just 200 light-years from the galactic centre. They found that some parts of this cloud were moving faster than others. Oka and colleagues then turned to the European Southern Observatory's Atacama Large Millimetre Submillimetre Array radio telescope ALMA in Chile to study the cloud in more detail. They observed an extremely dense region near the cloud's core which was also displaying varying velocities. Adjacent to this region, the authors detected a point radio source, similar to but about 500 times weaker than the type produced by an AGN or active galactic nuclei, a sure telltale sign of a supermassive black hole. Combined, the AGN-like radio source and the differing speeds of different parts of the gas cloud all pointed to an extremely massive object occupying a very tiny region within the cloud cluster. And that's important because the definition of a black hole singularity is an infinite density in zero volume. To confirm their suspicions, the authors then conducted computer simulations based on the gas cloud's velocities at different points in the cluster, concluding that an intermediate-sized black hole, about 100,000 times the mass of our Sun, provided the best fit for their observations. The discovery, if confirmed, supports the idea that supermassive black holes may be formed through the mergers of intermediate-sized black holes near the galactic centre. To find out more, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
This is new. This is news. This has sort of hit the headlines this week. An enormous black hole, which is also named Andrew's bank account, about 100,000 times more massive than the Sun, has been found lurking in the Milky Way galaxy. This is a very interesting and somewhat amazing find.
I think lurking is the right word, Andrew, because we haven't known about this black hole till now. And it is an amazing find. And I'll tell you why in a minute. But let me just explain the circumstances of how this has been discovered and put in a bit of background. First of all, we live in a galaxy. We call it the Milky Way galaxy, this huge swirling disk of stars and gas and dust, something like 100,000 light years in diameter. And of course, a light year, as everybody knows, is 9.5 trillion kilometers. It's a long way. So 100,000 of them is even further. It beats the global world outside Dubbo into fits, I can tell you. So we are about halfway between the center and the edge. And when we look in towards the center of our galaxy, about 25,000 light years away, actually we're looking towards the constellation Sagittarius. That's the direction in which the center of the galaxy is. It's actually where the Milky Way is at its brightest and thickest, and that's because there is this huge aggregation of stars near the center of the galaxy. Okay, so we've known for about the last maybe 20 years with increasing certainty that at the very center of our galaxy there is a black hole. And this one is indeed a supermassive black hole. Its mass has been measured by the motion of stars that are orbiting around it to be about 3.6 million times the mass of the sun. We're measuring it in millions of solar masses. That's the sort of standard yardstick for these supermassive black holes. Now, we think pretty well all galaxies have a supermassive black hole at their center. And one of the great hot topics in astrophysics and cosmology these days is which came first, the black hole or the galaxy. And it's probably the case that they evolved together. But galaxies seem commonly to have a supermassive black hole, sometimes far more massive than the one at the center of ours. We know of supermassive black holes more than 1 billion times the mass of the sun. In the centers of galaxies. So these things we lump together, as you've probably gathered by now, under the heading of a supermassive black hole. Now, on the other side of the coin, we see black holes in galaxies which are not much more massive than the sun, maybe 10, 20, 50 times more massive than the sun, 100 times more massive than the sun. And we call those stellar mass black holes because they've got the mass of a massive star, roughly the mass of a star. And they probably originated from stars that have exploded at the end of their lives. Stars much more massive than the sun explode at the end of their lives, create a black hole, and you get something that maybe weighs 20 times the mass of the sun. But here's the puzzle, Andrew. There's nothing in between them.
Yes.
You've got these things that are, the mass of a star, things that are nearly the mass of a galaxy, and nothing in between.
Yes,
and
we've had a chat about that before. There's no medium-sized black holes in basic terms.
That's right. We've got a fancy name for them. We call them intermediate mass black holes because they are intermediate between the big ones and the small ones. Look, there's no holding we astronomers when it comes to fancy names for things. Intermediate mass black holes. So what's the great outcome of this story? Well, we found one.
Yeah.
And that's why it's exciting. So what's happened is a group of scientists, actually Japanese scientists, although they've been using a European telescope. It's a radio telescope called ALMA. ALMA, of course, is an acronym for the Atacama Large Millimeter Array. It's operated by the European Southern Observatory and a few other institutions as well. In northern Chile, it's actually in the northern Atacama Desert. I've been there. The telescope's at a height of about 5 kilometers, so you can hardly breathe when you're
Sounds amazing.
It is pretty amazing. So it's an array of telescopes, radio telescopes, that look in what we call the millimeter region of the spectrum. And that's a great way of probing gas clouds in space. So what the Japanese astronomers have done, led by an astronomer at the Keio University in Tokyo, they've been probing gas clouds not too far from the galactic center, maybe 200 light years from this supermassive black hole, the middle of our galaxy. And they've found this cloud of gas, and it's gases that to us are completely toxic. There's sort of hydrogen cyanide and all kinds of stuff in there. There's quite an agenda, carbon monoxide.
You're talking about my wife's cooking now, aren't you? Carry on.
I'm not going there, Andrew. I'm definitely not going there. But so this cloud of gas, and what they've found is that there are sort of churning motions in these gases that can only be caused by something very, very compact and very, very massive at the center of the gas cloud. What is it? Well, it's so compact and so massive that it can only be a black hole. And the key thing is that it's about 100,000 times more massive than the sun. Now, that sounds like a lot, but it's much less than a supermassive black hole. And that qualifies it as one of these elusive intermediate mass black holes. So this is an indirect observation. Black holes, you always observe them indirectly. Principally, you observe them by looking at the motions of things around them. And in this case, you're looking at the motion of gas around the black hole. So they've published a paper in Nature Astronomy, the prestigious, probably one of the most prestigious journals in the world. They speculate that this newly found black hole could actually be the black hole that used to be at the center of a dwarf galaxy that was basically subsumed into our own galaxy, because that's what big galaxies do. They gobble up smaller ones. Yeah. And actually, we think that's how black holes become supermassive, because they gobble up smaller galaxies with their own black holes, and that adds to the black hole at the center of the galaxy. So this looks like a very, very nice piece of work that, as I said, probably answers one of the big questions that astronomers have been asking for many years. Where are the intermediate mass black holes? Here's one that we found.
But does it, Fred? Because in all the years that you and I have spoken, there's one thing that sticks in my mind. We have found one, and that doesn't prove that there are others. But if we find another, then the dominoes start to tumble. It's the same as the life in the universe question. We only know of one planet with life.
Exactly. That's so you're right. That's right. It's a single example, but you can bet your life there'll be more turning up in due course as astronomy technology improves and we find more interesting bits of the universe to look at. So a great story. And I'm very encouraged by this.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program Space Nuts. And this is Space Time. I'm Stuart Gary. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. The Sun has just erupted the most powerful solar flare of the current solar cycle. It was one of two significant solar flares which erupted on September the 6th. The Sun undergoes an 11-year solar cycle, during which the Sun's activity waxes and wanes. The cycle is triggered by reversals in the Sun's magnetic north and south poles. The current solar cycle began in December 2008, with the peak of activity, known as solar maximum, occurring in 2014. The cycle is now decreasing in intensity, heading towards solar minimum. That's expected in 2019 or 2020. Solar minimum is a phase when solar eruptions are increasingly rare, but history has shown that when they do occur, they can be intense. NASA's Solar Dynamics Observatory spacecraft, which watches the Sun constantly, captured images of two X-class solar flares on September the 6th. Solar flares are powerful bursts of radiation. Solar flares are classified according to their strength. X-class donates the most intense flares, followed by M-class, C-class, B-class, and the smallest flares near background levels are labelled as A-class. Similar to the Richter scale used for earthquakes, each of the 5 levels of letters for a solar flare represents a 10-fold increase in energy output. The first of the solar flares peaked at 7:10 in the evening Australian Eastern Standard Time. That's 5:10 a.m. US Eastern Daylight Time, while the second larger flare peaked at 10:02 in the evening Australian Eastern Standard Time. That's 8:02 in the morning US Eastern Daylight Time. Both September 6 flares erupted from an active region on the Sun, labelled AR2673. The same area also produced a mid-level solar flare 2 days earlier, with about a tenth the strength of the flares measured on September 6. In fact, the AR2673 region has continued to produce a significant level of solar flare activity, with 2 more flares on September the 7th, and then another extremely powerful eruption, the second biggest in the current cycle, on September the 10th. In fact, the September 10 event, also detected by the Solar Dynamics Observatory spacecraft, generated an X8.2 class coronal mass ejection, or CME, strong enough to produce an S3-level solar radiation storm and a ground-level radiation event. Only about 10 S3-level solar radiation storms are generated during any single 11-year solar cycle. Energy and particles from solar flares and coronal mass ejections are normally held at bay by Earth's magnetic field, which acts as a protective shield, and if they pass through that, by Earth's atmosphere. However, in a ground-level radiation event such as this one, high-energy particles make it all the way to the planet's surface. In fact, the strength of the September 10 event would have briefly doubled the radiation dose normally experienced aboard commercial airliners flying at higher latitudes. These events also affect high-frequency radio communications and terrestrial electricity grids, overloading circuits and transformers and triggering widespread power blackouts. In space, these events damage satellites by frying delicate electronics. They also cause damage to solar panels. They cause atmospheric changes which degrade satellite orbits. They affect communications and navigation satellite systems and pose significant radiation hazards to astronauts. The event also sparked spectacular auroral activity, with the aurora australis or southern lights reportedly putting on a stunning display across southern Australia. Scientists say this event would have been even stronger had the AR-2673 region which triggered the eruption been facing directly towards the Earth instead of being on the Sun's limb and the process of revolving around to the far side of the Sun. This resulted in Earth only getting a glancing blow. This is Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. And a new study has found that fictional portrayals of autistic people, such as the Big Bang Theory's Dr. Sheldon Cooper, are reinforcing autism stereotypes. A report in the journal Psychiatry Research claims these portrayals tend to be unrealistically aligned with textbook diagnostic criteria, and so don't accurately reflect the variety of autism seen in real life. Researchers from the universities of Edinburgh and Oslo analysed Dr. Sheldon Cooper's character, along with 25 other fictional autistic characters from TV and film. They judged each of the characters against the standard criteria that doctors use to diagnose autism, known as the Diagnostic and Statistical Manual of Mental Disorders, or DSM-5. Most of the characters displayed at least 9 of the 12 defining characteristics of the condition. In reality, this level of alignment with the diagnostic criteria is rare. About half of those analysed were portrayed as being a genius or having some other exceptional skill, such as Dustin Hoffman's character in the 1988 film Rain Man. In reality, researchers say fewer than 1 in 3 people with autism have such a skill. And the researchers warn that this narrow view may be reinforcing widely held stereotypes about autistic people. A new study has found that the decline of the world's cold tundra regions because of human-induced climate change is now inevitable. These regions, known as periglacial zones and which contain a layer of permafrost, make up about a quarter of the Earth's land surface and are mostly found in the far north and south at higher latitudes and also at high altitudes. Scientists from the universities of Exeter and Helsinki and the Finnish Meteorological Institute examine natural processes caused by frost and snow which take place in these zones. Their findings suggest that even with the most optimistic estimates for future carbon emissions, areas covered by periglacial zones will dramatically decrease by 2050 and will almost disappear by 2100. This would have major impacts on landscapes and biodiversity, and it could trigger climate change feedback processes that could either amplify or diminish the effects of climate change. Scientists studied 4 processes which take place in periglacial zones, including snow accumulation sites and frost churning, which refers to the mixing of materials caused by cycles of freezing and thawing. Their results forecast a future tipping point for these processes, causing fundamental changes in ground conditions and related atmospheric feedbacks. Even based on the most optimistic estimates for future carbon emissions, researchers predict a 72% reduction in the current periglacial zone. And by 2100, periglacial zones will only exist in very high mountain regions. A new study claims husbands aged 50 or older having a, shall we say, generously proportioned wife, I think I got away with that, substantially increases the husband's risk of developing type 2 diabetes. The study, presented at the European Association for the Study of Diabetics annual meeting in Lisbon, is the first to investigate the sex-specific effect of spousal obesity on diabetes risk. The research also suggests that the over 55s with a spouse with type 2 diabetes tend to be more obese than their peers without a diabetic partner. The authors say that obesity or type 2 diabetes in one partner could lead to type 2 diabetes in the other due to the many risk behaviours that lead to diabetes shared by couples, such as poor eating habits and little physical activity. Scientists reached their conclusions after examining the association of spousal diabetes and obesity in 3,650 men and 3,478 women aged 50 or older. Participants were interviewed every 2.5 years between 1998 and 2015. Over the average follow-up period of 11.5 years, the new case rate for type 2 diabetes was 12.6 for every 1,000 people per year among men and 8.6 among women. The researchers found no statistically significant indication overall that having a spouse with diabetes increases one's diabetes risk. However, further analysis showed that husbands with an obese wife were significantly more likely to develop type 2 diabetes during follow-up. For every 5 kilograms per square metre higher body mass index in his wife, the husband's type 2 diabetes risk was 21% higher when accounting for the man's own body mass index. However, conversely, women with an obese husband had no additional risk for type 2 diabetes beyond that of their own obesity level. A new study claims the transition from dinosaur to bird, which occurred in reptiles millions of years ago, was accompanied by profound changes in the skull roof design of those animals. The findings, reported in the journal Nature Ecology and Evolution, is the first to track the link between the brain's development and the roofing bones of the skull. In the process, it's providing important clues about changes in these animals' brains. Across the dinosaur-bird transition, the skull transforms enormously and the brain enlarges. The researchers were surprised that no one had directly addressed the idea that the underlying parts of the brain, the forebrain and midbrain, were correlated or somehow developmentally related to the overlying frontal and parietal bones. Although previous studies had shown a general relationship between the brain and skull, associations between specific regions of the brain and individual elements of the skull roof have remained unclear. And that's led to conflicting theories on some aspects of skull development. Scientists discovered that most reptile brains and skulls were remarkably similar to each other. But it was the theropods, the dinosaurs most closely related to birds, as well as the birds themselves, that were divergent, with enlarged brains and skulls ballooning out around them. They found clear relationships between frontal bones in the forebrain and parietal bones in the midbrain. Researchers now believe this relationship may be found across all vertebrates with bony skulls, and probably indicates a deep developmental relationship between the brain and the skull roof. The research team says this implies that the brain must be producing some sort of molecular signals which instruct the skeleton how to form around it. And finally for now, scientists at the Australian National University, the ANU, have found a new way to store quantum data long enough to share the information around the next generation internet, which promises to be impervious to hacking. The work, reported in the journal Nature Physics, addresses a crucial challenge which has eluded researchers worldwide. The study's lead author, Associate Professor Matthew Sellers, says the improved storage was an important part of a viable quantum internet to connect quantum computers globally. The team used a rare earth element called erbium in a crystal to increase the storage time of telecom-compatible quantum memory by 10,000 times compared to previous efforts. Erbium has unique quantum properties and operates in the same bandwidth as existing fibre optic networks, thereby eliminating the need for a conversion process. The research showed how an erbium-doped crystal was the perfect material to form the building blocks of a quantum internet capable of unlocking the full potential of future quantum computers. Quantum memory allows scientists to buffer and synchronize quantum information, operations necessary for long-range, ultra-secure encrypted communications. At the moment, researchers are using memories that don't work at the right wavelength and have to employ a complicated conversion process to and from the communications wavelength. The new technology can also be operated as a quantum light source or used as an optical link for solid-state quantum computing devices, connecting them to the quantum internet. The technology can also connect many different types of quantum computers, including the ANU's silicon qubits, as well as the superconducting qubits which Google and IBM are currently developing. You're listening to Space Time. I'm Stuart Gary. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.